Hey guys, Jake here, coming at you with another math problem today. Today I wanted to show you another one of the formulas on my integral calculus cheat sheet that I came out with recently. There's a link down in the description and in the pinned comment below where you can check out where to get that. It's available for instant download. It's very affordable, only a couple bucks. You can go download that right now and I'll show you how to use one of the formulas on that study guide. Today we're going to be going over a continuous compounded interest formula, the continuously compounded interest formula. Basically this video is essentially going to be showing you how to use that formula. Kind of like, you could think of it almost like a continuously compounded interest formula calculator. Before we jump into it, be sure to hit that like button and that subscribe button down below. You don't want to leave YouTube algorithm up to decide which videos you get to see, so be sure to hit that subscribe button and the bell icon next to it so you see all my videos, and I'll help you get better grades throughout your calculus term, so you be sure to come back for all the rest of them. So without further ado, let's jump right into it. So here's the problem we're going to be going over today. If $1,000 is borrowed at 8% interest, find the amounts due at the end of 3 years if the interest is compounded A, quarterly, and B, continuously. So obviously this is kind of a two-part question. The full question that I got this from, it has several parts, different rate frequencies that the interest is being compounded. But basically there's kind of two different categories when you're talking about compounding interest. The, quarterly, annually, semi-annually, all these types of compound interest where it's compounded a certain number of times per year, those are all going to use this formula that I already have written here on the left. So that's what we're going to use for part A, and the other parts, if you wanted to compound it monthly or whatever, would all work very similarly with, basically one small difference. The other kind of case that you want to consider is compounding continuously, which is the main thing I wanted to show you about in this video, because this is the formula that we actually can grab right off of my integral calculus cheat sheet that I talked about earlier. When you're doing these types of problems, first thing you want to do is, figure out which formula is going to be applicable based on how frequently your interest is being compounded. And like I said, if it's continuously, we're going to use this one. Otherwise, we're going to use this one. So let's kind of just talk about for a second the different pieces in these formulas. So in both of these cases, what this is meant to represent is the total value of the investment or the total value of the loan that you have to pay back. In this case, we're borrowing $1,000. So we basically are having a loan that we're going to have to pay back at the end of 3 years. And what we, kind of want to figure out basically is this formula tells us what the balance of the loan is at any given time T that we plug into this formula. So T is going to be in years. T is a number of years. So obviously if we're trying to figure out the balance after 3 years that we have to pay back, our T that we're going to be using in this case is going to be 3. Our A sub 0 is just the initial value of the loan or the initial value of the investment. So in this case, we're borrowing $1,000. Our A sub 0 is going to be 1,000. The R is going to be the interest rate. And keep in mind, this is not going to be as a percentage, it's going to be as a decimal. So we're going to have to take this 8% interest that we're given and convert it into a decimal. And then N in this formula is the number of times per year that your interest is being compounded. So in part A here, we're going to do quarterly. So if it's compounded 4 times per year, that's what quarterly means, each quarter of a year, our N is going to be 4. So basically, to figure out part A here, all we really have to do is plug in all those pieces I just mentioned to figure out the balance of the loan after 3 years. So the T, like I said, is going to be 3. So we're putting in 3 for T. Our A sub 0 is our initial balance, or our initial value of the loan. 1 plus our interest rate, which is 8%. 8% as a decimal would just be 0.08 over N, which is the number of times it's compounded per year. If it's compounded quarterly, that means 4 times per year. And then that's going to be raised up to the N times T power. So again, N is 4 and T is 3. So we could put 4 times 3 as our power. So basically this formula will tell us the balance of the loan after 3 years. So if we simplify this or plug it into a calculator, 0.08 divided by 4 is 0.02, plus 1 would give us 1.02, raised up to the 12th power, and then multiplied by 1,000. And if you plug that into a calculator, you would get this number here, 1,268 and 24 cents. So that would be the amount of the loan that would have to be paid back after 3 years if it was compounded quarterly. So now what I really want to show you is basically how to do this same thing that we just did in part A, but now our interest is going to be compounded continuously. Right, so the continuous compound interest formula is this right here. A of t equals a sub 0 times e to the r times t. This formula is a little bit easier to work with because basically this 1 plus r over n to the n has kind of been converted into e to the r. So it's a little bit easier to work with because you can see we're just going to have, again, t equals 3. We're still going to be looking at 3 years, what that looks like. And again, we just want to kind of plug in these different pieces. So our a sub 0 is just our starting amount, $1,000. E is always going to be E. And then R, again, is your interest rate converted to a decimal, which is again going to be 0.08. And then your T is going to be 3. So basically we just get this to figure out what our total balance is going to be if it's compounded continuously. And again, we can just plug that into a calculator. And doing that will tell us that we're going to end up with $1,271.25. So again, you can kind of see how close this compounded continuously number is compared to this compounded quarterly number that we got in part A. You know, really the more frequently that you're compounding your interest, that's just going to result in a little bit more interest being accrued. So the more frequently you compound your interest, the higher amount that you should have after a given time. And in this case, we can see that compounding it continuously ends up with just a little bit higher balance that has to be paid back than it would if it was compounded quarterly. So if you found this video helpful, please be sure to hit that like button down below. There's a couple other videos over on the left side of your screen over there. If you want to check those out, should be helpful for you. And please be sure to hit that subscribe button below. Be sure to, come back for my next videos, join the Jake's Math Lessons community. Together we'll keep crushing it all term in calculus. Don't let YouTube decide which videos of mine you get to see. Make sure you come back and see them all, because together, I promise, we'll be able to help get you some better grades in Calc. Thanks, and see you next time.